This is the introduction to Activity 2.3, Tile Figures and Algebraic Equations. The purpose of this activity is to learn to use algebra piece models to answer questions about sequences of tile figures and to solve basic algebra questions. To learn to use algebra equations to build tile figure sequences and to connect the work with algebra piece models to the corresponding symbolic steps. We'll use black and red tiles, black and red end strips, and black and red edge pieces. In this activity, we introduce the two-column method. To show our algebra piece work, we'll use a two-column table to display the work. This helps us model and visualize our work, and at each stage helps us connect the algebra piece model to the corresponding symbolic steps. Here's how we solve questions with algebra pieces and the table. We'll sketch our algebra piece work in the left column, algebra piece work, and we'll write the corresponding symbolic steps in the right column, symbolic equations. In both columns, we'll also include brief notes about each step to make sense of our work and to emphasize the correspondence between the left and the right column components. You can model an equal sign on your workspace by using two black edge pieces, and you can model large numbers by using scraps of paper or writing. When you subtract in the algebra piece model, you can't really subtract tiles from each side. Instead, for example, to subtract 5 black tiles, add 5 red tiles to both sides, which creates 5 0 pairs. And then in the right column for the symbolic steps, that corresponds to subtracting 5. Similarly, to get rid of 5 red tiles on the left, you could add 5 black tiles to each side. Here's an example of the two-column method. For t equals 2n plus 5, which figure has 35 black tiles? So we'll use the two-column method and check our solution. We start by modeling 2n plus 5 as 2 end strips plus 5 black tiles. And then as the next step on the left with our algebra piece work, we set that equal to 35. On the right, we have our equations. T equals 2n plus 5, and then 2n plus 5 equals 35. As a next step, we need to get rid of those 5 black tiles, so we add 5 red tiles to each side. That 35 marker is 35 black tiles, so 35 black tiles plus 5 red tiles simplifies to 30 black tiles. On the right, we subtract 5 from each side and simplify to 2n equals 30. Next, we divide each side into 2 equally sized groups, 30 divided by 2, and we end up with n equals 15. Finally, we check. If n is 15, we can see in our algebra piece model that we have 15 plus 5 is 35. Next, we need to model consecutive figures. We frequently look at consecutive figures in our algebra questions. For example, the n plus first, and the n plus second figures in a sequence. The table shows modeling just a black end strip and the next two consecutive numbers, n plus 1 and n plus 2. You can see in the table we have an end strip, that's n, and then we have our n plus 1 figure, which is the end strip plus 1 black tile, and the n plus 2 figure, which is the end strip plus 2 black tiles. Of course, those were very simple examples. So those figures can be part of more elaborate figures, and in our examples we have lots of edge pieces and markers to show dimensions to make the examples make sense. You don't necessarily need to use the edge pieces in your work. It should always say. So let's look at t equals 2n and then figure n plus 1 and n plus 2 as illustrated here. You can see at first we have 2 times n, then we have 2 times n plus 1, then we have 2 times n plus 2. And you can correspond the function t of n is 2n, 2 black strips, t of n plus 1, 2n plus 2, 2 black strips and 2 black tiles, and t of n plus 2, 2 black strips and 4 black tiles. Looking at a different function, t equals n plus 2, we start with 1 black strip and 2 black tiles. Then for figure n plus 1, the black strip grows by 1 tile, so now we have n plus 3. Then in figure n plus 2, the black strip grows by 2 tiles, and now we have n plus 4. Combining these ideas together, we have t equals 2 times quantity n plus 2. So now our figure n has 2 times n plus 2 as the edge dimensions, which gives us 2 black strips and 4 black tiles. Figure n plus 1, both of the n strips grow by 1, so we end up with 2 black strips and 6 black tiles. And figure n plus 2, the n strip grows by 2, each of them, so now we end up with 2 black n strips and 8 black tiles. Of course we can do this with red pieces too. We just need to be extra careful about how the red strips grow. So let's look at some examples. For t equals negative 2n, in this illustration we have negative 2 on the left. Of course those could be switched. It could be 2 times negative n. And we have all red tiles. So 2 red n strips. Then for figure n plus 1, each of the red strips grows by 1, so that grows by 1 red tile. And you can see the growth pattern and the symbolic equation all match. When we put n plus 1 into negative 2n, we end up with negative 2n minus 2, which matches our 2 red n strips and 2 red tiles. Then figure n plus 2 will have 2 red strips and 4 red tiles, or negative 2 minus 4. If we look at negative n plus 2, which we can think of negative quantity n minus 2, we have a combination of black and red tiles here. On the left we have negative 1, and on the top we have n minus 2, a black end strip edge and 2 red edge pieces. And you can see that this all combines to minus n plus 2. For figure n plus 1, again the red strip grows by 1 red tile, and the edge pieces are just keeping track of the signs. And then we still have our 2 black tiles. And then in figure n plus 2, the red end strip grows by 2 red tiles, and we still have our 2 black tiles. Then combining all of these, we have negative 2 times n plus 2. And so we have the same ideas as before, now only with 2 rows. So figure n has 2 red strips and 4 red tiles. Figure n plus 1 has 2 red strips and now 6 red tiles. And figure n plus 2 has 2 red strips and 4 red tiles. You'll get lots of practice working with consecutive figures in activity 2.13.